So now we are going to look what projectile motion is. Basically, a projectile motion is one in which an object performs two-dimensional motion. That is basically it moves in the horizontal plane as well as in the vertical plane as shown in this diagram. So here's an object. This is basically a white ball, let's suppose, and it travels in the vertical plane as well as in the horizontal plane. That is the reason why it has a curved path. So moving on, there are some basic questions which we would do. So first question says find the horizontal component of the initial velocity. So in this we would use the concept, we would take help of the concept of our vectors and basically the resolution of vectors. So what we could do is we could make a horizontal component and a vertical component of this velocity. So, and this will make a right angle triangle. So to find the horizontal component of this velocity, what we have to do is to use the formula 20 cos 30 degrees, and the reason is that since cos of theta is equals to adjacent or base divided by hypotenuse, and when we cross multiply the hypotenuse with the cos of the angle, you get the adjacent or the base, that would be hypotenuse cos theta. Just replace the values, and the hypotenuse is 20, cos theta is cos 30, and you would get the answer. That would be 17.3 meters per second. Moving on to the next question, it says find the vertical component of the initial velocity. So the vertical component, we know that this is my perpendicular and this is my hypotenuse. So the best formula would be sine of theta equals to perpendicular divided by hypotenuse. And to find the perpendicular, what we have to do is to multiply hypotenuse with sine theta and replace with the given value. So 20 times sine of 30, and the answer comes out to be 10 meters per second. And the best way to confirm if the answer is correct or not, like if 17.3 and 10 meters per second are the correct answers, then the best option is to find the resultant velocity, that is in this case 20 meters per second, by using the Pythagoras theorem. Square this and square that 10 meter per second component, add the square of these answers and then square root the answer, and you would get the answer 20 meter per second. So moving on, there are two notes. So the first note is based on the vertical component of velocity, and that is the vertical component of velocity gets influenced by the pull of gravity, because gravity acts in the vertical plane. So that's the reason why vertical component of velocity gets influenced by the pull of gravity. So the vertical component becomes zero as you reach to the highest point, and the reason is that as you are going up, up, and up, there is a constant downward force of gravity that is opposing your upwards velocity, and that's the reason why over a period of time it would decrease, and at one instant the vertical component of velocity becomes zero. So as you reach the highest point, and then it increases in the opposite direction, as you know, because it reaches zero at the highest point and then it has to increase because still the pull of gravity is there, so it increases in the opposite direction, and then in the direction of the gravitational force. So this would be some sort of a depiction of the velocity of the object at different points in its motion. So corresponding to this path, the velocity time graph of this object would be, at this instant the velocity would be the maximum, at this it would be the least or the minimum, and this would be the negative maximum because the direction is negative, and here the direction is positive. So positive and negative maximum, and because vertical velocity was calculated to be 10 meters per second, so what we could do is take 10 meters per second on each side, to minus 10 and plus 10 meters per second, and just make a straight line, not a horizontal one, a straight line, however a slant one, and this tells us that there is a constant deceleration, and the reason is that only the acceleration due to gravity is acting on my object, and it has a constant value, and that's the reason why the gradient of velocity time graph is also constant. Moving on, the next note says that since acceleration due to gravity acts in the vertical plane only, it does not affect the horizontal motion because acceleration due to gravity only acts in the vertical plane, so the horizontal motion would not be affected, and that's the reason why we could safely say that the horizontal velocity of the object would remain constant from the start to the end or throughout its motion. The object horizontal velocity would remain constant, and that is the reason why at each point in its motion the object would have a constant velocity, and so the graph of its horizontal velocity would be something like this: a horizontal line, a horizontal straight line, and the reason is that, and the value was 17.3. The reason is because since there's no opposing force and there's nothing to resist or oppose the horizontal velocity, so that's the reason why my horizontal velocity would remain the same throughout the object's motion. Okay, now moving on, there are some points that are very integral and necessary. So the points are vertical velocity changes continuously, and the reason is because acceleration due to gravity would also act in the vertical plane, and that's the reason why vertical velocity changes continuously. Horizontal velocity will remain constant because there's no force that is acting in the horizontal plane, so the horizontal velocity remains constant, and the gravitational force acts only in the vertical plane, so horizontal velocity wouldn't be affected. Then acceleration acts only in the vertical plane. Again, the reason is that there is a change in velocity only in the vertical plane, and there's no change in velocity in the horizontal plane. If there's no change in velocity in the horizontal plane, then there's no acceleration. And if there's a change in velocity in the vertical plane, then only acceleration would be present in the vertical plane. Then the last one says if air resistance is negligible, then we can separately apply equations of motion for the vertical and the horizontal motion. And the reason is that velocity would decrease at the same rate in the at a constant rate in the vertical plane, and there would be no air resistance, and the time taken in the vertical plane would be equal to the time taken in the horizontal plane. So that would eventually help us in using the equations of motion separately. And here is an example where we could um, apply equations of motion separately in for the horizontal and vertical motion. So here's an example. So it says that there's an object and there are no specific values. Everything is just in is theory, and everything is just based on variables. So it says that there is an object which has completed its projectile motion. So the first question says at which point its velocity is zero, and we all know that velocity is never zero. And the reason is that you could argue that velocity is zero in its maximum when the object reaches its maximum height. However, the case is not this. The case is that the vertical velocity becomes zero. However, the horizontal velocity still has a value. So there is no point at which velocity is zero. Then the next question is mark the direction of acceleration at all 5 points. The acceleration direction would be vertically downwards, and the reason is that acceleration acts only in the vertical plane. So all the arrows would be pointing vertically downwards, and the reason is that first, why vertically? Because acceleration due to gravity acts in the vertical plane, and why downwards? Because gravitational force is directed downwards. So something like this. So arrows would be equal equal length of arrows and downwards. All right. So then it says mark the direction of the force. So we know that F equals to ma, and force or acceleration points in the same direction. So the answer would be the same as before, vertically downwards, and because it does not make any difference whether it's a force or acceleration because it's point in the same direction. Then the last question says how to mark the direction of resultant velocity at point A. So the easiest way to do this is, because let's say if this is a projectile motion, so always and always at any point that tangent to the point would be the direction of the resultant velocity. So what we have to do, there's a tip, that is by constructing a tangent at the point on the curve. So here are some examples. Example questions using variables rather than absolute numbers. So this is again based on the previous parts and previous questions. However, it's just for help purposes because it makes it easier um to quickly get the answer and rather than doing the complete working. So the initial horizontal velocity in the projectile motion of an object would be u times cos theta, where u would be the initial velocity of the object and theta would be the angle of the resultant velocity made with the horizontal. The initial vertical velocity would be found out using u sine theta. Again, u would be the initial velocity and theta would be angle between the resultant velocity and the horizontal. And then it says expression for vertical velocity after t seconds. So we know that v equals to u plus at, and in the vertical component we know that the initial velocity is again u sine theta as we already calculated, and acceleration we already know is due to gravity. However, it would be negative, and the reason is that gravity is directed downwards and we take downwards as a negative direction, and everywhere we have to assume in for these explanations that we are taking upwards direction as a positive direction. So minus g would be because of the gravity being directed downwards, time the time taken. So the final velocity in the horizontal plane, oh, sorry, in the vertical plane would be u sine theta minus the gravitation force into the time taken. Then moving on, it says expression for horizontal velocity after time t seconds. So it would be again the formula would be horizontal velocity remains constant throughout. So the only formula would be u cos theta, that is for the initial velocity because horizontal velocity remains unchanged. Then moving on, the question says expression for calculating horizontal distance after t seconds. And since the horizontal velocity remains constant, so the formula that could be used is distance equals to speed into time, and why we want to use the s equals to ut plus half at squared formula. The reason is that acceleration in the horizontal plane is zero because there's no change in velocity, and if there's no change in velocity then this whole expression becomes zero. So the best answer is speed times time, and speed is u cos theta as we calculated in the previous part. Moving on, the question says expression for calculating vertical distance after t seconds. So in this case, you will use this formula s equals to ut plus half at squared, and we already know what is the initial velocity. We have already calculated, that is u sine theta, and we just have to put it in the formula. So u sine theta, that is the initial velocity, into the time taken plus half into the acceleration, that is again would be negative of force due to gravity and or acceleration due to gravity, and the reason is that we take upwards as positive and gravity is directed downwards and into time squared. Then the question says expression for time taken t to reach a maximum height, and it is, and we already know that the final velocity would be zero because at the maximum height the velocity always becomes zero because we already learned in the previous part. So what would happen, that our formula, the best formula would be v equals to u plus at, where theta could be, where v where theta could be an angle and my final velocity would be 0, and it could be equated to u sine theta plus minus g, that would be the negative of acceleration due to gravity times the time taken, and we could make time the subject to find out the time taken to reach the maximum height. Then it says expression for total time t of the journey, and the reason why we have multiplied it by 2 is because when we calculate the time taken to reach the maximum height, it is always and always half of the original time taken. And because half of the original time taken, because this is the half distance that is traveled, and this remaining half is not calculated to find out the maximum height. So what we do is whenever we calculate the time taken to reach maximum height, this is this portion. So we multiply it by 2 to find the total time taken to cover this whole distance. So that's why the formula becomes twice of u sine theta divided by g. Okay, so this is the last part of kinematics, and it is half projectile motion. And it, is, it says that a particle is projected horizontally from the top of a cliff as shown with an initial velocity of 20 meters per second. As you can see, the diagram is new. Okay, what is half projectile motion? Originally, we learned that a projectile motion is something like this. So half projectile motion, as the name itself suggests, would be the half of it. So something like this. Alright, and the equation of motion would remain the same and there would be no change in it. So moving on with the calculations, the question says that the initial velocity of the object is given to be 20 meters per second and the vertical height is 80 meters and the distance from its original position to the point where it falls is x meters. The question says that the horizontal velocity would remain constant, and the reason is that since there is no resistive force acting in the horizontal plane and acceleration acts only in the vertical plane, so horizontal velocity would remain constant. And since it is projected horizontally means that the only force and the only direction of velocity of the object is towards the right, and there is no vertical velocity. So this tells us that the initial vertical velocity of the object will be 0, because again the object initially was pushed towards the right side, or the initial velocity was just towards the right. So towards the right means that there is no vertical plane. Then it says that however as it moves the vertical velocity starts to increase, because then under the influence of gravity the object falls, and so the vertical velocity of the object starts to increase. So the question says that calculate the time taken to reach the ground. So we just have to apply the formula. And the best formula in this case would be s equals to ut plus 1 upon 2 ad squared, because we know what's the initial velocity and we could already, and we know that what's the displacement, and we know what the acceleration is due to gravity, and so we just have to put in the values, and displacement is 18 meters, because we know that we learned from the previous video that we could separately apply the equation of motion of vertical and horizontal components and use the same time as we did in the previous question. So we could take just one of the planes, and I am taking the vertical plane because we know the maximum values of the vertical plane in order to find out the time taken. So 0 times t plus half of a, that would be 9.81, and because sign convention says that downwards is positive, so acceleration would be positive, times t squared, make t the subject, so it becomes t equals to 1.9 seconds. So there is a general formula to this to find out the time taken. So it is y, that is in this case that will be the displacement, time equals to 0 times t, because 0, the reason there is a 0 is because initial velocity of the vertical plane is always 0, so 0 times t would also be 0, plus half of g is acceleration due to gravity, into time squared, and making t the subject, we get this general formula, that is total time taken to reach the ground is equal to under root of 2 times of the displacement divided by the acceleration due to gravity, that is 9.81. Alright, so the next question says that calculate the horizontal distance. So we already know that horizontal velocity remains constant. And keeping this in mind, we can use the formula distance equals to speed into time, where distance is to be found and speed is known to be 20 meters per second because initially it was directed towards horizontal. And taking this rightwards direction as positive into the time, it could be, we already know that vertical time, the time taken in the vertical plane would be equal to the time taken in the horizontal plane. So we could just use this time period calculated into 1.9, and the total distance in the horizontal plane would be 38 meters. So again, we have a general formula for this, and that is distance equals to speed into time, where speed would be the initial speed of the object because initially the object has only the horizontal component of the speed, and times the time, and we already found out the time, that was under root of 2 times of the displacement divided by acceleration due to gravity. So we can multiply u with under root 2 times y divided by g. And in terms of variables, or we could say the general formula to find out the horizontal distance traveled, it is x, or that is horizontal distance traveled, equals to the initial velocity multiplied by under root of twice of displacement divided by acceleration due to gravity.